Manholes would be fairly easy to maintain if it were not for the interface between the foundation-like barrel and cone section and the chimney section, which moves with frost cycles at the surface. The manhole chimney as it exists today is a disaster. When rain falls, it contacts the ground surface and works its way downward around the manhole structure. Rainwater will enter at the first opening, and those are found in abundance in the manhole chimney. The concrete adjusting rings in most structures have a design strength of 3,500 psi, which may not hold up well when being regularly exposed to water and freeze-thaw cycles. Sulfides inside the structure are particularly damaging to concrete as well. One of the first processes that occur in a manhole is the cracking and settling of the surrounding road surface. Water leaks into the manhole chimney section, carrying with it fines from the road base, causing more settling and cracking. As water washes through the chimney, it weakens the concrete adjusting rings and they start to fail under traffic impact loading. To counteract the settling problem, some designers have opted for a large square of concrete or asphalt around the manhole frame. Square repairs have serious weaknesses in the design. There are planes of weakness at the thin points and large moment arms at the corners. To implement a full penetration road cut at the square corners requires a large overcut, leaving a maintenance problem. It requires a huge concrete saw using an expensive wet cut diamond blade to perform the road cut. Some crews prefer not to use a saw and will penetrate the road using an air hammer. Air hammer cuts are almost always sloping, which causes the repair to heave from frost. We've addressed the problems with current methods of fixing manhole chimneys, and that leaves us with 3 questions. What would a repair that addressed all these problems look like? What kind of systems would be necessary to create the repair? And how would we stay within our budgets while using such a system? In answer to question number 1, the repair would be round. 20% less material is used in round repairs. There are no planes of weakness as there are in a square repair. Round repairs are easily reinforced. Full penetration cuts without overcuts are not possible using a square repair, but with a round cutting device you can achieve this. The repair would match the color of the roadway for aesthetics. The structure would be perfectly level with the height and slope of the road. This makes future repaving operations and adjustments of the manhole frame easier. When we talk about using ready-mix concrete in the repair, the issue of expansion coefficient differential between asphalt and concrete is raised. Remember, the roads that we're putting the repair in are often asphalt, and we're using concrete for a repair. So let's talk about the expansion coefficient differential. Just how big of an issue is that? If you'll look at the drawing, you'll see a ruler. The first hash mark is 1/16 of an inch. That's the accuracy that we're shooting for in this type of construction. If you'll look at the edge of the dollar bill in relation to the 1/16 of an inch hash mark, you can see that it's very small. Alongside that dollar bill, as we zoom in, you'll see a very small layer. That's the actual expansion coefficient differential. So we can put that issue to bed. It's really not an issue. Another possible objection to using ready-mix concrete in the roadway is the possibility of salt damage. Let's look at what salt could possibly do to a ready-mix repair. You're looking at a repair that's been in the road for over 4 years. It is located in the Midwest. It's been subjected to a lot of de-icing chemicals, and it has suffered some spalling because of that. As we zoom in on the repair, you'll see that on the left is the asphalt, and on the right is the concrete repair. Ready-mix concrete really is a good option for these repairs. The worst case scenario, they just look more like asphalt. Cupping and mounding can occur with asphalt. There will either be too much material placed in initially and it can't be rolled flat, or traffic loading can push the material down and you'll get a cupping. This does not occur with ready-mix concrete. Our design objective is to remove the many horizontal joints that are in the traditional chimney structure. With ready-mix concrete, we can achieve that one-piece repair and eliminate possible leakage or structural weaknesses. The repair method must work well with masonry structures. The repair will begin 12 inches below the road surface. For structural reasons, we want to make sure we have at least 12 inches of concrete for traffic to run over. The repair will widen the support base and transfer loads away from the masonry structure. The repair must work well with spray coatings, either polyurethanes or cementitious. It must have an inner surface that acts as a barrier to hydrogen sulfide gases. The repair should have a seal or series of seals to prevent the structure from leaking even when being moved by frost, and it must be vacuum testable.